Hi, this set of notes is over the last section in chapter 4 that we're going to do. It's 4.6 over slope, and it's completely a review session from Algebra 1. Your central question is, how can I recognize the relationship between the slopes of parallel and perpendicular lines? So just to review what slope is how slanted, how steep, or how shallow a line is on a coordinate grid specifically. We represent slope with the letter M. You might have recognized it in a few equations last year that you used. One was slope-intercept form, which is y equals mx plus b. So here was the slope right here. B, if you recall, is the y-intercept. This is where your graph crosses the y-axis. So there's one example of where you would see slope. You would also recognize it perhaps in the point slope form of a line, which is y minus y1 equals m times x minus x1. So here's m again. y1 and x1 are the coordinates of any point on the line. So that's just any point. And you just put those here and here. And then you've got the slope where m is. So how do you find slope? You can find slope a couple ways. If you've got 2 points from a line, you can find the slope of the line by subtracting the 2 y values of the points and then dividing that by the difference of the 2 x values of the points. What's really important when you use this formula is that the first y value and the first x value, the 2 values that you're subtracting from, are from the same point, and that the numbers, the values that you're subtracting from the other point are both from the second point. Sometimes, especially in science classes, you'll see that difference of y2 minus y1 written like this. Looks like a triangle. It's the Greek letter delta. Delta y over delta x. And this delta literally means the change in. So whenever you're seeing how something changes, you just subtract them. It means the change in. So you would say that as the change in y or the change in x. The way that we find slope on a graph, we can actually count it. And that's called the rise over the run. And we find this from 2 points on a coordinate grid system. The rise is the vertical difference between the 2 points, and the run is the horizontal distance between the 2 points, which is really just the change of the y values and the change in the x values. So please make sure that you recall all this. On your formula chart, this part of the formula will actually be on there. The formulas for these different forms of a line are also on your formula chart. So there are 4 different types of slope. If your line moves up from left to right, we say that it has a positive slope. If your line moves down from left to right, we say that it has a negative slope. And it will literally be a negative number. If your line moves horizontally, we say that it has a 0 slope. It actually has a value of 0. The way that the equation of a horizontal line like this would be y equals some number. And that number is just where that line crosses through that y-axis right here, this point right here. So like this one, for example, might be y equals 3. Okay. The other way that your line could look, it could be a vertical line that crosses through the x-axis, and the equation of it would look like this. X equals some number. So for this one, that number might be 4. This would be x equals 4. And the slope of this line is that it has no slope. Or we say it's undefined. Okay, it has no value. So we've got positive, negative, 0, and no slope. These are the 4 different ways your lines could look. Now, we've got this little thing that you can use to help you remember, and that's this guy called Mr. Slopeface. Okay? He's got some eyebrows. You can make him look mean or nice. We'll make him look nice. Usually around Halloween I make him look mean, but here are his eyebrows. This first eyebrow on his right, our left, the eye underneath that eyebrow looks like this. And the eyebrow under the other, or the eye under the other eyebrow looks like that. His nose looks like this. And then his mouth, he's not so happy. He's just kind of like there. It's just straight across. And it looks like this. He's got a little soul patch under his mouth, or a little tiny beard. So the way that this guy works is these are the 4 different types of slopes. And his eyeballs and the U and the O, these are how you can remember the types of slope that these kind of lines have. We've got positive slope, negative slope, undefined, that's what they use for, and 0 slope. So there's Mr. Slopeface. Woohoo! We will talk about the relationship between 2 specific types of lines. Those are parallel lines and perpendicular lines. Parallel lines have the exact same slope. So an example of what parallel lines might look like this. Parallel lines are lines that will never intersect. So they must be angled the same way. They have the exact same slope. The way that we show that, the symbol, is we put like a little arrow through both of the lines, not at the ends, but somewhere between the ends. And that means those 2 lines are parallel. So we could say this line, we'll call it slope M1, and we'll call this line slope M2. Because they're parallel, we will say that M1 equals M2. They are equal. So an example of slopes that are parallel could be anything. We could have a slope of 1/2 and 1/2. We could have a slope of 3/4 and 3/4. We could have a slope of -6 and -6. 2 numbers that are exactly the same. When the slopes are the same, the lines are parallel. Now perpendicular lines, they have opposite reciprocal slopes. So we'll talk about that in a second, but the way perpendicular lines look is that they intersect at a right angle. And this is something we've talked about a lot this year. And we know if there's one right angle, then all 4 of these are right. So let's say the slope of one line we'll call M1, the slope of the other line we'll call M2, and because they're opposite reciprocals, that means they're not equal to each other. They're opposites and reciprocals. So opposites means one is positive and one is negative. Reciprocals means that they are flips of each other. So the way that this would work, we could say the slope of one is equal to the opposite reciprocal of the other. This is the relationship between the 2 slopes. If I put in some numbers, you can see it a little bit easier. Let's say the slope of one line was 3/4. If I write the opposite reciprocal of that, I'm going to change its sign, so now it's going to become negative, and I'm going to write the reciprocal of that fraction, which is the flip. I'm just going to switch 3 and 4, so it's going to be 4/3. -4/3 and 3/4. We could do another one. What if my slope was -9? If I write the opposite reciprocal of that, the opposite of that would be to make it positive, and the reciprocal would be to switch the numerator and denominator. Well, the denominator of -9 is 1. There's always an invisible 1. If I flip that, I'm going to get 1 over 9. And 1 over 9 needs to be positive because negative 9 is obviously negative. So those are examples of two slopes that are from perpendicular lines. Okay, so here's an example where we would need to look at slopes. It says describe the types of angles of quadrilateral ABCD, and we have coordinates here. So the first thing we probably want to do is to sketch what we think this looks like. All of these coordinates are positive, so we know we're going to be in the first quadrant. Okay, so first thing I'm going to do is plot these. A is going to be at 4, 7. 4, 1, 2, 3. Okay, so here is my quadrilateral ABCD. In order for us to describe the 4 angles in this quadrilateral, we really need to look at the slopes of the 4 segments to kind of see how they meet. So let's find the slope of each. We're going to find the slope of segment AB. We'll find the slope of segment BC. We'll find the slope of segment CD. And we'll find the slope of segment AD. Okay, remember how we find slope? We're going to subtract the y values on the top, subtract the x values of the bottom, and of course we're using these points that we've been given. So, remember with each one we've got an x and a y. Let's find the slope of AB first. We need to make sure that we're using the correct ordered pairs. The y values of A and B are 7 and 3, so I might do 7 minus 3. I need to subtract my x values of 4 and 1 in the exact same order. So since the 7 is from point A, that's my y value. The x value that's first also needs to be from point A, which is 4. So we'll do 4 minus 1. That simplifies to 4/3. Okay, for the slope of BC, I'm going to use those two ordered pairs. I've got 3 and 1 for my y's, so I might do 3 minus 1. If I do 3 minus 1, then with my x's, I need to do 1 minus 4. The 1 in the denominator needs to be from the same point as the 3 in the numerator, and the 4 in the denominator needs to be from the same point as the 1 in the numerator. So this is what I get. 3 minus 1 is 2, 1 minus 4 is negative 3. If the negative is in the numerator or the denominator, then the whole fraction is considered negative. If you end up with a negative in the numerator and in the denominator, 2 negatives, then the whole fraction is positive. For the slope of CD, my y values are 4 and 1, so maybe 4 minus 1. In my denominator, I'm going to have 4 and 8, those are my x values. And I've got to subtract them in the same order that I did my y values in the numerator. So 8 minus 4. 4 minus 1 is 3. 8 minus 1 is 4. So here's that slope. And then the last slope is between points A and D. My y coordinates of A and D are 7 and 4. So we could do 7 minus 4. And then my x coordinates of 4 and 8, I would need to subtract 4 minus 8 to be consistent with my numerator. When I subtract, I get 7 minus 4 is 3, and 4 minus 8 is negative 4, which means that whole fraction is negative. So now we kind of need to analyze what we've got here. Remember, slopes that are parallel are exactly the same number. And if I look at my 4 slopes, none of them are exactly the same. So that means none of these 4 segments that make up quadrilateral ABCD are parallel. When lines are perpendicular, they are both opposites, which means one's positive, one's negative, and they're reciprocals of each other. So if I look at my points, I can see, my slopes, I can see that this slope, the 4/3, and this slope, the negative 3/4, those are opposite reciprocals of each other. One is positive, one's negative. One is 4/3, one is 3/4. So that means those two segments are perpendicular. And those two segments, here's AB and here's AD. So that means right here, I've got a right angle. This angle is 90 degrees. Other than that, I can't make any really other conclusions about the angles in the quadrilateral, but I do know that that is a right angle. And I know mine doesn't look like a right angle, it's not drawn to scale, but we want to go by the calculations, and that's what they prove. So the practice problems for 4.6 are 1 through 5. Feel free to start on those. Otherwise, we'll do them in class. Hope you're having a great weekend, and I'll see you soon.